Hello! In this video, you'll learn the basics of making classes out of other classes through inheritance. Check out this class called Animal. It has a couple class variables and an instance variable. It overrides the built-in init method, and it has a method of its own called greeting. Now, let's say we want to make a class called Cheetah. Its instances will have a name, whose default value is animal. This name can also be printed by calling a method called greeting. The Cheetah class will also have a speed in miles per hour, represented by an integer, and a method called run that displays some indication that they are running to the console. Imagine if we had to just make another class from scratch. This seems like more work than we should have to do. Aside from the things highlighted, these classes are basically the same. Check this out. There's actually a way to specify in the Cheetah class that it should just have everything the animal class has, and anything we specify is either different or new. Look, all we did was put the class name animal in parentheses after the word cheetah. We can then get rid of anything in the Cheetah class that isn't different or new. This is called inheritance. We say that the Cheetah class inherits from the animal class. We also say that animal in this case is the superclass and cheetah is the subclass. Now let's use diagrams to illustrate what happens as we put these classes to use in a program. Here we have our animal class. It has a couple class variables. And here is our cheetah class. It has a couple class variables, one of which has the same name as a class variable in animal. And of course, the cheetah class is a subclass of the animal class. Let's look at what happens as we try to access these variables through the different classes first. This line is pretty straightforward. Python looks in the animal class for a class variable called kingdom, finds it, and prints it. If we try to print cheetah's class variable called kingdom, Python first looks directly in the cheetah class. When it doesn't find what it's looking for, it then looks in the superclass. This is sort of like how Python may look in an instance and then in a class for a particular variable. If you can't wait to see how all this works when you have a superclass, a subclass, and instances, don't worry, we'll get there.
Oh boy.
When we want to print the food description variable in animal, this is simply a direct access. When we want to do this for the cheetah class, it is also a direct access. Unlike with kingdom, Python doesn't actually need to continue its search to the superclass, even though there is also a variable called food description in the superclass. This is an instance of shadowing. In this particular case, the variable called food description in the cheetah class shadows the variable called food description in the animal class. Printing the speed variable in the cheetah class is pretty straightforward. And notice that we cannot access the speed variable through the animal class. A subclass can access class variables in the superclass, but not the other way around. Okay, let's pretend that last line wasn't part of our program. For this part of the lesson, I've changed each class to only include the names of its variables, and I've added the names of the methods, greeting in the animal class and run in the cheetah class. Here, we've made an instance of each of our classes. The first one, A, has its name instance variable set to the default value of animal. The second one, C, has its name instance variable set to the value speedy. We can print C's name by directly accessing the name variable through the instance. If we try to access the speed variable via C, Python looks first in the instance, and then in the class. Now check out this variable lookup. If we try to print c.kingdom, Python looks first in the instance, and then in the class, and if it still hasn't found anything called kingdom, it continues looking in the superclass. Now let's look at an example of a method call. When we call a.greeting, Python looks in A's class for a method called greeting. Now, remember that the code for greeting prints self.name. In order to execute this code, Python must look up self.name, which is basically the same as looking up a.name. Now, since name is an instance variable in A, this is pretty easy. Okay, what if we call c.greeting? This also involves both a method lookup and a variable lookup, and for both, Python just follows the usual chain of command. First, it looks in C's class for a method called greeting, and when it doesn't find it, it checks the superclass. It then performs the usual variable lookup on name in order to execute the code for greeting. If we change a variable, class or instance, that change has the potential to affect everything downstream from it. In this case, later in the program, if we change the kingdom variable in the animal class, this change has the potential to affect a bunch of things. By default, animal instances will look up to the animal class's version of this variable. So will the cheetah class, and by extension, all cheetah instances. Of course, if we define a variable called kingdom on the cheetah class or on an instance of either class, some degree of shadowing will happen, which limits the impact of changing the variable kingdom in the animal class. I'd highly recommend working through the animals example in this lesson to see some of the ways in which shadowing can occur when we have a superclass, a subclass, and instances. Okay, brain break with our friend the red panda before we move on to the last couple concepts in this lesson. Okay, break over. Let's look at this scenario. We create a list that has 5 things. The 0th and 2nd things are instances of animal. The 1st and 3rd things are instances of cheetah. And finally, the last thing is just the number 2. Notice that you can create anonymous instances of the animal and cheetah classes in this list. You don't actually have to assign them to variables. You can just create them using the name of the class and parentheses. The same way you would on the right side of the equal sign if you were assigning these instances to variables. Now let's say you write a for loop over your list, and what you want to do is call the greeting method on each thing that is actually some type of animal. If you just call thing.greeting, without checking first to see if it's an animal or a cheetah, you'll end up accidentally calling the greeting method on the number 2, which doesn't have a greeting method. What you have to do is use the isinstance function. This function takes 2 arguments, an object and a class name, and returns true if the object is an instance of the class or an instance of a subclass of the class, and false otherwise. In this case, the first 4 things in this list pass the test. Both animal instances and cheetah instances will cause isinstance to return true if the second argument to it is animal. The number 2, on the other hand, is in no way, shape, or form an instance of the animal class. This causes the else branch to execute. Okay, now I want to bring this slide back. Let's say in the Cheetah class, we want to make speed an instance variable instead of a class variable. We can do that by making a constructor that is specific to the Cheetah class. The problem here is that since animal's constructor is no longer used, the instance variable name does not get set. We can fix this by setting it in the Cheetah constructor. This still isn't great though, because we might add another instance variable to the animal class later, and it would be easy to forget to add it to the Cheetah class too. Fortunately, we can actually just call animal's constructor from Cheetah's constructor. This way, we can be sure that everything that would be set up in an animal instance will be set up in a Cheetah instance. We can then add whatever we want to the Cheetah instance afterwards. In general, if you have a superclass and a subclass that both define constructors, the first thing you should do in the subclass constructor should be calling the superclass constructor. Okay, let's summarize all the inheritance concepts at play here. In this case, the cheetah is the subclass and the animal is the superclass, and the subclass inherits from the superclass. You can think of inheritance as an is-a relationship, or an is-a-type of relationship. For example, a square is a type of rectangle, so we would say square inherits from rectangle, or square is the subclass, and rectangle is the superclass. In this case, a cheetah is a type of animal, so cheetah is the subclass, and animal is the superclass, or cheetah inherits from animal.